I have been up to no good in C#, particularly in Unity, actually. And I wanted to share some stuff that I think would help understand what static does in C#. I thought it'd be kind of clever to explain static not using C#, but a different language. This is basically LUA. The screen isn't really important at all. This is just sort of familiarizing you with the language itself. It executes top to bottom. Nothing in particular I want to bring up about this. This screen here, however, is interesting because this is basically a static class. So previously I just had my stuff just out everywhere. I had functions I can call, but this, I have functions that are attached to a sort of central object, and they do things related to counting. I've called it counting machine. I mainly do this for organization, but this again is helpful for changing the way you think about static classes. Basically, I have one object that I cannot make many instances of, so I can't do something like that. That would be like the C# equivalent, but this is LUA, doesn't really know what this is. There is only one of these things. There is only one counting machine. Now I wanted to talk about something that you might be familiar with or might not think too much about, and that is instance, like class instances, let's say. Technically I have a central object here, but all this central object called countCell is doing is creating and spitting out instances. So you can think of this kind of like a constructor. So what instances are, so if you look at this function here, we have a counter object that's being made, and that's local, so inside the scope of this function. And there's some stuff that happens and we spit that counter out. This is the return of the function. So it'd be easier to think of it like this. You look sort of near the end where I'm finishing my definitions, and I have an instance A and an instance B, two counter objects that are are they distinct from one another? They are, yes. So as you can see in the constructor, I input a start and an end number. So the instances have the same kind of function. There's a count function and it will go from start to end, but they have unique data, the start and end points. And this is basically what an instance is. It's the same kind of a thing. You can have as many as you want, but you have to keep track of the instances yourself. So calling count on instance B, yeah, that counts from 6 to 9. Calling count on instance A should count from 1 to 5. There we go. And yeah, so this is like a regular class. This is like a static class. And again, the difference between these is I can instantiate these, and I have to keep track of the references, but they're the same kind of thing, but the data may be different. Whereas a static class, there's only one of them. There is only one. The special thing in C# is that you do not have to keep a reference to your static classes or static items. So one thing you can do in LUA that you can also do in C#, you can have static data and instance data all in the same thing. We have our countCell, again we have a constructor, but we also have a static function. Right at the top of my scope here, this little do and end, I have, you can think of this as like an array or a list. I'm going to keep track of every instance that I create, and I'm going to have a static function that counts the number of instances I create. So let us make a bunch of instances and call that static function to see what happens. I should count to 7, right? Yep, so I have 7 instances. So yeah, mixing static data in like a class could be pretty interesting. Just keep in mind that static, you can think of it as meaning there is only one of these, so there's only one instances list. In my case, I should have named this something else, but this is something to be careful of because there can be some funny bugs that result between getting confused between what is unique to this item versus what all the items are sharing. But again, can be pretty useful. So this is the final thing I want to mention, the singleton pattern. So here we go again. This is kind of similar to before. We have basically a constructor that makes instances that we can instantiate and things. However, there is a special static function, you can see it, that just gets a static instance. This is kind of weird. So I can actually instantiate this thing, instantiate counters, the little thing that's returned. Let's just say for some reason I'm not keeping a reference to any of these counters and I just wanted to get one of them. I could just get, in my case, the last created instance and run the, do whatever I want, so run the count function. So this doesn't make a whole lot of sense in this environment at all, really, because this is basically like I want there to be one object that I can always get, and we're using it in a way that it's like it's static, there's only one of them. So why not just use a static object? Why do we want a static object that we can also instantiate? Doesn't really make a whole lot of sense at all. Again, in this environment, and that is a key distinction. In Unity, because of how statics interact with the framework, this ends up making a lot of sense and is something you have to do. Now, the following example kind of sucks, but I think it'll be okay. So here we are in Unity. I got the inspector open, and the focus is on these three things right here. So there's an empty, another empty, and another empty. These things are going to make a prefab model. They're cubes. And so I can set their scale to be a custom scale, XYZ, or I can have them use a scale that's going to come from a static object from somewhere. Let's go ahead and take a look at that. So this is the static object. As you can see, I defined it here. There is a cube scale property on it. And by default, this is 222 on X, Y, and Z. Now, the thing that's actually making the cubes is over here. So you can see, there it is, that prefab that I can change, custom scale, whether or not to use it, and scale. So this is the manual input. So basically what happens is when the editor actually starts, it's going to spawn that prefab, it's going to instantiate it, it's going to set its position, rotation, and it's going to pick which scale it wants to use. If it's not using a custom scale, it's going to use our sort of like default scale from that static object. And this is kind of one of the best part about static items, is that you do not require a reference to access static data. This thing just kind of exists, the assembly knows about it, and it can just get it. So here's what happens when it actually runs. I suppose I should have put an update on, but you can see the first and last cube are not using a custom scale. The second one is, and I have basically overwritten it. So again, this example isn't great because, I don't know, the static could have been a part of basically this, because you can just do statics as part of an instance class, but humor me. So okay, statics are great. I can put one-of-a-kind data in here and I can access it from anywhere without needing to keep track of the reference. I don't have to, make another thing, let's say cube machine. I can't do this because I can't like, the reference is like always alive. It's a static class, it's not an instanceable class. Now, the problem with statics in Unity, like honest to goodness statics, is that, okay, there's my cube machine script. I can't do anything here. I can't really drag it anywhere. Can't be abstract. Basically, I cannot interact with this. Any data I put in here has to be basically hard-coded or set by some other means, but I can't interact with this. On the other hand, my cube cell, the thing that actually lives on the game object, I can interact with this. There's settings I can change. I can drag this on things. The whole part of like Unity is, being able to interact with the objects you make, the scripts you make, and you can't do that with static objects, and you can't inherit from Mona behavior either. You're not allowed to. So you can still use statics in Unity, as you can see I'm doing it here. But if I need to, take advantage of the functions that come with Mona behavior, like start update, fix update, all that, I'm not allowed to use like a static as the main object. It has to be some secondary object somewhere, as I'm using it here. So in the process of running this tutorial, I just realized that the scripts that were on these items weren't actually cube cell, but the other script was close enough. It was doing basically the same thing, so I'm not gonna redo it. But what we're here to talk about now is singletons. So I've made another object called static thing, and here you can see we have something called cube machine singleton. What could that be? Well, remember this is our cube machine. This was just a static class. So our cube machine singleton is a singleton. Once again, a singleton. So let's take a look. So you can see that it's not a static class. You can see in the inspector I have a scale vector that I can change, and it should be static. Anyway, static. So remember that you can mix static and unstatic. However, in static classes you can only have static items. But anyway, there's this thing called instance that is of type cube machine singleton. So there can only be one of these, and all of the instances of cube machine singleton have access to this. It's a singleton. And I have access modifier, so only this thing can actually set the property. And what I'm doing is in awake before start, important because that needs to be defined before anything wants to access it. I'm setting the instance. So right now the cube cell is using the cube machine cube scale, so that is the static thing that we can't really interact with. Let's have it use the, oh right, so we have to do cube machine singleton dot instance dot cube scale, and this is usually how you access static data. You are basically accessing an instance, so you have to access the instance first because the instance is static. Actually, explaining this sounds really stupid and just weird, but okay, you can see the instance is the thing that's static here, and every instance has a cube scale property, so you have to go through the instance to get the property you want. So it's kind of a mouthful to type, but there you go. So what we're interested in is if we go to the static thing, you can see I can interact with it. So let's make it really tall on the y-axis, and let's see what happens. And there we go. This, if you want to be able to change something in the editor, this is the closest thing you can get to static in Unity. Or if you want to take advantage of, again, the mono behavior functions like awake, update, start, all that. Alright, on to some practical examples, I suppose. So, as far as full-blooded static items, again, because I can't really interact with them, they're kind of rare. However, they can still exist, so I really like using events. So in every namespace in a certain project I have, there is an events static object. So basically anything, anywhere, can subscribe itself to one of these events. And if you're wondering about this is, I'm not sure how healthy this is, but this is mainly meant for things in the namespace to call broadcast. Probably not the most healthy thing to do. I have been using singletons a lot, so here is something called storage. And once again, I really wanted something static, but Unity, this is the closest thing I can get if I want to actually be able to set up some things in the inspector. If I want to use mono behavior things like awake. So in my case, what this thing does, yeah, you can see responsible for accessing game save files. Okay, cool. Now an interesting thing is that usually I do not use the .instance part on my singletons because I write them in such a way that there's like some internal like a getter and setter that basically accesses instance. It's still a singleton. That instance needs to be defined or you're gonna get a null reference exception, but you can see all of my functions are static. There are no instance functions except for awake, but that's a private function that doesn't really count. So anything that wants to access the storage object just doesn't need to use the instance necessarily, but I still do have a get on it and it's public. So here you can see, yep, a static function, save objects. So anything that needs to, or that wants to trigger a save, it just does storage.save objects. It doesn't do storage.instance.save objects because there is only one save objects function. There's no unique instance function for saving objects. This is one example of that. I guess I can show you an example of where this would be used. So let's see. Namestate. So I believe it's referenced here. Yeah, you can see storage. So I'm using a lot of namespaces, but yeah, serialization, storage, delete save. You can see I don't have to do instance.delete save because, let's see, it's not an instance function. It's not unique per instance. It's a static function. Again, really useful as well because I don't need a reference to that thing. Because it's static, it just kind of exists, and you can see even this is a singleton. Why is this a singleton? Oh, because I need like start and awake and all that. Yeah. Which is another thing. Yeah. Even if you don't need to be able to set data in the inspector or set it up in the inspector, whenever a scene is loaded or exited, for example, you want to have access to the monobehavior functions. Again, you have to take the framework into consideration. But I think that's gonna do it. It looks like I went on a lot longer than I thought I would. I thought this would be like a 10-minute video, but whatever. Hopefully, this helps you with figuring out whether or not you should use a static piece of data or a static class, or maybe clears up some things that you're not sure about. Because I actually like using static items, and again, I would use more full-blooded static things if Unity had like support for it. But again, use a singleton. Don't feel bad about it. Alright, with that being said, I'll see you around.